Good morning, guys. We're going to start our trig function unit, and that's where we're going to take all the trig ratios, trig functions that we worked with in the last unit, and we're actually going to start graphing them by stretching them out along the x-axis and seeing what the values that we were able to calculate would look like as a graph. Now, we're going to start that by looking here at the unit circle and looking at how sine and cosine, when we take all of these points from the unit circle and put them along the x-axis, stretch this thing out horizontally, what that curve is actually going to give us. So if we just start with the y equals sine of x, very, very basic sine curve, sine function, we'll start at 0 degrees. Now, there's my initial side. Well, at 0 degrees, I stay on the positive x-axis. Remember, inside the unit circle, sine is the height of the point on the terminal side that intersects the unit circle. So the height of this point at 0 radians is going to be 0. It has no height. So sine y equals sine of x gives us 0. Now, we'll rotate on around and we'll just hit these quadrant angles. So if I rotate on around up to 90 degrees, the height where the terminal side intersects the unit circle at this point is going to be 1 because it's the one unit circle. It has a radius of 1. So at 90 degrees or pi over 2 radians, we are now at a height of 1. We'll keep rotating on around down to 180 degrees. So at 180 degrees, you can see the height is again 0. So at 180 degrees, which is pi radians, our height is at 0. And we keep working our way around 270. We have a height or a sine of -1. So we're down here at -1 at 270 degrees or 3 pi over 2. And then all the way around back to 360 degrees, which was 2 pi, puts us back at 0. Now, as you can see, if I kept rotating around, it would put me back to a height of 1. And then again to a height of 0. So we get this function that repeats. So it's a reciprocating function. Now it's just going to keep going through this wave, bouncing between +1 and -1 forever in both directions. If we had gone negative angles going to left, we would have started out at -1. So we would have dropped down to 1. So we get this curve where this is described as one cycle of the curve. It was one trip around the unit circle to create this curve, but it keeps going forever. Now that's one cycle of a sine curve. Notice it starts on what we call the sinusoidal axis, this line that runs right through the middle of it, and it finishes on it. Now, y equals cosine. Let's look at a cosine graph. Using the same idea, if I started here at 0 radians, remember cosine is the width of the point inside the unit circle on the terminal side. So the width at this point is 1. Rotate around to 90 degrees. The width of this point is going to give me 0. It has no width. So at pi over 2, we're at 0. Down to 180 degrees, our width is at -1. 3 pi over 2, our width is going to be at 0 again. And at 2 pi, the width is back to +1. So we get this shape right here for one cycle of a cosine function. And what you'll notice is that these two look very, very similar. Well, the reason they look so similar is because of the definition or the relationship between sine and cosine. Remember, we in the last unit, we defined sine and cosine as cofunction, using that cofunction identity, where we said that that sine of x equals cosine of pi over 2 minus x. Okay, guys, we just looked at the general shape of sine and cosine functions. Now let's look at how the equation or the pieces within our equation tell us what the shape's going, how the shape's going to be manipulated, how we're going to move it horizontally, vertically, stretch it out, things like that. Now, you should remember from Algebra 2 that the general form of a sine function or cosine function would look like this, where we can have a coefficient on the actual trig part and a coefficient on the x. Now just remember back to all the work we've done with transformations all year long. If I'm doing something to my parent function, it's something that's vertical. If I'm doing something to just the x portion, it's something that's horizontal. So a is being multiplied by the sine or the cosine, so that's going to stretch us vertically. Well, that's all amplitude is. It's the vertical stretch. So absolute value of a is going to tell us how far up and down our graph is going to go. So we knew that if we had that in that original function we did, it was just going to be up 1 and or up to positive 1 and down to negative 1. Well, if a is some other number, then that's going to change it. So if a was 2, it would stretch our unit circle to a 2-unit circle. So we'd go up to 2 and down to negative 2. Or if a was a 1/3, it would shrink our unit circle to a 1/3 unit circle. And we would then have up to 1/3 and down to negative 1/3. So a just tells us how high our graph's going to be. It's just the amplitude of the graph. The next thing we looked at was the vertical. We would want to look at is the vertical shift. And that's k. Anything we add on to the end of the parent function is going to be how far up and down we're moving our graph. And that's just going to take our sinusoidal axis. That's the graph, the line that runs right through the middle of our graph. The sinusoidal axis is going to move up if k is positive, down if k is negative, and now we can manipulate and move this graph all over the place. Horizontal shift, that's something we add or subtract from x, so that would be h, same transformations we've been doing all year long. So that's going to tell us, instead of starting at the origin or on the y-axis every time, we can shift this thing left and right. That's actually, like we talked about a few minutes ago, well, the cosine is just a horizontal shift 90 degrees of the sine function because they are co-functions. And then period. Y'all remember from your science courses or back from Algebra 2, period is going to be how long one cycle is. So the cycle typically is 2 pi. If I just had sine of x or cosine of x, there's 1 unit circle. We're just moving around one time. The period is going to be 2 pi. Well, b is a coefficient of x, so b is going to affect how far or how long that one cycle is. So 2 pi over b, because remember if we multiply by b from all our transformation work, multiply by b is actually going to shrink us by a factor of 1 over b. So it's going to take our factor or our normal period of 2 pi and shrink that by a factor of 1 over b. So the period, the length of one cycle is 2 pi over b. And we'll work through a whole lot of examples here in a couple of minutes. And that doesn't really matter if it's sine or cosine. Increments is just going to be the period divided by 4. Increments are the period divided by 4. And that just comes back to there's the 4 quadrants. There's the 4 different parts of each of our sine and cosine functions. So we just want to show that it's spaced equally and we get the same shape through each quadrant or through each portion of the curve. So that's where the increments come from. You just do the period divided by 4. And finally, the direction. Now, as we can see, sine and cosine, everything is the same from amplitude, so vertical shift, horizontal shift, period, and increments. The only thing that's going to be different is the direction. And the reason the direction is different is because of how we get sine and cosine and which quadrants are positive and negative. Now, when we're working with these, A is going to tell me what I'm doing vertically. B is going to tell me what I'm doing horizontally. So sine can be affected both vertically and horizontally. And it can be affected by both of them. So if A is positive, then that means we're going up. If A is negative, we're going down. Well, since sine is the up and down graph, then that means that it's directly affected there by A. So if A and B have the same sign, both positive or both negative, then our graph is going to increase coming out of the sinusoidal axis. Remember, sine is going to start on the sinusoidal axis, but then it's going to increase coming out. If A and B have opposite signs, then the sine graph is going to decrease coming out of the sinusoidal axis. So it would start out by going down. Now cosine is going to be the opposite of that, or not the opposite of that. Cosine is actually going to look at if A is positive, then we're going to start at that maximum point. Cosine is going to start up top, and then it'll come on down from there. If A is negative, well, that's negative on the outside is a vertical reflection, so we'd flip our graph over, so then cosine would start at that minimum point and come on up. The reason cosine is not affected by B is because B is the angle. Well, for cosine, remember, since cosine is horizontally what's going on, if I rotate it up or rotate it down, I still have the exact same relationship going on horizontally. Where with sine, if I rotate it up, I have a positive value. If I rotate it down, I'd have a negative sine value because sine is the up and down value. But since cosine is the horizontal, my horizontal doesn't change if I go up or down. It's still going to be on the right side of the y-axis if we're just talking about quadrant 1, quadrant 4. So cosine is only affected by A when it comes to direction. Sine is A and B. Cosine is just A. Everything else for sine and cosine graph is going to be the same. And let's go work a couple problems and put all this together. Okay guys, let's go ahead and work a few examples where we take these functions and actually put a graph up there. We're going to graph one full period of each function, so that means we're going to go through the cycle and then stop before we start the picture again. Now, we just went through what the definition of each of these things is, so let's use those definitions to find these 6 different aspects of this sine graph. Now, if we look through amplitude, remember amplitude is absolute value of A. Well, A was this lead coefficient, so the amplitude in this case is going to be 3. So that means from wherever our sinusoidal axis is, we've got to go up 3 and down 3. That's our high and low points, our high and low values. Vertical shift, that was K. That's whatever we're adding on to the end of the sine function. So in this case, we're adding a -1 on. So that would represent down 1 unit. So we're no longer going to be on the x-axis. We're actually going to be down. Our sinusoidal axis is going to run through y equals -1. Horizontal shift is anything we're adding in here with the, or subtracting from the x. We're not subtracting anything from the x. So there is no horizontal shift in this problem. Period. Period was the length of one cycle. Typically it's 2 pi, but we have a formula 2 pi over b. And realistically it should be 2 pi over the absolute value of b. So 2 pi over 2 is going to give us pi. So one cycle is only going to be pi units long. So this 2 has actually shrunk our graph in half. Increments was period over 4, period divided by 4, so that is going to be pi over 4. So instead of every 90 degrees, every 45 degrees, we get a fourth of our graph. And then direction. Remember direction, we looked at A and B. If A and B for sine are opposite signs, then the graph is going to decrease. Decrease coming out of the sinusoidal axis. So, for our initial point. So let's go through and let's build this graph. And let's put the vertical shift in there. We usually start at the on the x-axis. We're going to shift this down to -1, so that our sinusoidal axis runs at -1 now. Okay, -1. Now from there we need to go up and down 3. So our high point is going to be 1, 2, 3 points above that. Our low point is going to be 1, 2, 3 points below that. So it'll be -4. So we can already see our graph is no longer between 1 and -1. It's been stretched out and moved down. Horizontal shift, we have nothing to worry about there. The period. Period we use to find the increments. So our starting point, that's what we really want to know. Well, the starting point is typically at x equals 0. Well, in this case, we didn't shift it left or right at all, so it's still at x equals 0. And we're going to start on the sinusoidal axis, for a sine curve. Then our next point is pi over 4 units away. So plus pi over 4 is approximately pi over 4. Pi over 4 is about 0.79. So if we draw our increments on the x-axis, 1, 2, 3, 4, 5, 6, 7. All right, well, let's just put some extra values on there. And we'll go a couple negative. So we only want to go over 0.79. So we're going to go over to about here. And that would be pi over 4. Then we're going to go another pi over 4 units. Well, pi over 4 plus pi over 4 is pi over 2, which is about 1.6. So 1.6 would put us at pi over 2. I'll write that a little bit bigger so you can read that. So we've got pi over 4, pi over 2, another pi over 4 puts us at 3 pi over 4, which is about 2.3 or 2.4. So we'll say that that's 3 pi over 4. And then another pi over 4 should complete the cycle, which should be pi, which we know because our period was pi. So start at 0 and go pi distance, you're going to get pi. And that's 3.14. That one we should all know. And you can just punch each of those in the calculator, pi over 4, pi over 2, 3 pi over 4, pi, to get the decimal approximation. So there's going to be the 4 parts of our graph. So let's put it together. We know we start on the sinusoidal axis for sine. Direction told us to decrease, so I'm going to decrease to my minimum. So at each of these increment points, I should be either at a low point, a high point, or on the sinusoidal axis. So I'm going to drop down to my low point because it told me I have to decrease because my sines were opposite. Okay. Then at my next one, I can't go below -4. Remember, everything's got to stay between these 2 points. So I bounce up back to the sinusoidal axis. Now at the next increment, I'm going to go and be at my maximum point. My 3 pi over 4 is going to put me at 2. So you can see we're just bouncing between these 2 points. And we should either be at a low point, a high point, or a middle point at each of those increments. And then we're going to come down and finish back at pi. So we get this graph right here, which is a little too stretched out vertically there. But we can see, remember, we started, our original graph was between 1 and -1. So we see we stretched that and shifted it. And our original graph also went from 0 to 2 pi. Well, we've cut this thing down in half because what B tells us is the number of cycles we can get from 0 to 2 pi. So we can get 2 of them from 0 to 2 pi, the original distance that we had. So that's this example right here. Now let's look at a cosine graph. Okay guys, sorry, Hanson just interrupted me. We're going to go graph this cosine function now. Start with the amplitude again. Amplitude is absolute value of A. So the absolute value of 2 is 2. So this one's going to go up and down 2 from the sinusoidal axis. Vertical shift, whatever we're adding on to the end, which is nothing in this case. And here we've got the addition going on inside the cosine. So it's a horizontal transformation. That'd be horizontal shift. It's got to be outside all of that stuff for it to be vertical. So there's the horizontal shift. Remember, the horizontal shift is h. Remember, your form is b times x minus h. So minus h would be minus pi. So we're shifting left pi units. Period is 2 pi over b. 2 pi over absolute value of -1/2 is going to be 4 pi. Multiplied by reciprocal, so divided by 1/2 is times 2. So that 2 times 2 is 4 pi. Increments are going to be period over 4. So 4 pi over 4. Each of those increments is pi units wide. So it means each curve, each of those 4 parts of the graph is going to be pi units wide. And then the direction. Remember, for cosine, I don't look at both A and B. I only look at A because B does not affect the direction of cosine. So if I look at A is positive, so positive graph is going to start up. So for direction, A equals 2, which is positive. So our direction is going to start in the, starts at max. It starts in that up position. Starts in that maximum position. So let's go ahead and graph it. Our start point is typically at 0. We had a horizontal shift left pi units, so we should be starting at negative pi. So we get negative 3.14. That's going to be our first value. Then we add pi each time because the increments were pi. So if I add pi, negative pi plus pi is 0. So 0 is going to be my next break point. Add pi again. 0 plus pi gives me pi, so 3.14. It's going to be my next break point. Add pi again gives me 2 pi. So that's 6.28. 2 pi, and then add pi one more time to close it off. So that's a 9.42, 3 pi. Okay, so we've got these breakpoints. The amplitude was 2. We didn't shift it up or down at all, so it's just 2 and negative 2, and now we can actually put this graph together. Direction, remember for sine or for cosine, we're going to start at one of either the high point or the low point. So our direction in this case told us to start at the max because A was positive. So at my leftmost value, I'm going to be at my high point of 2. I'm going to come on around 0, or can only decrease from there, so I've got to come down to 0. And I keep working my way down to negative 2. Once I go another pi unit, then I'm at the bottom, so I've got to work my way back up to the top. So I've got to cross that sinusoidal axis, and I'm going to finish up at 2 when I'm over here at 3 pi on the x-axis. So we put together the 4 pieces of our graph, and then there's our cosine function. We can see, remember initially, that very first picture we drew of cosine, it was between 1 and negative 1, and the whole picture fit right in here. It would have looked like that. So you can see we have shifted it pi units, we have stretched it out 2 units tall, and then we've stretched it out horizontally so that we can get only half a cycle in there from 0 to 2 pi. So all these different transformations took this original picture and turned it into that picture. So we have graphed sine, graphed cosine. They're very, very similar direction, and your starting point is really the only difference in them. But if we've got these values, which really is just your normal transformations that we've been using all year long for different types of functions, you get those values, then we can put together this sine and cosine function. See you in the morning, guys.